Okay, let's see question 12. 12 talk about a bell-shaped distribution. And I will explain that. So we're going to use the mean of 8.44 and standard deviation of 1.49 and something called empirical rule. The empirical rule. And the question is asking what percentage of American women have shoe size that between those two data. Okay, so let's first learn bell curve distribution. People call bell curve or normal distribution, right? So one of the probability distributions. Remember in class I talked about the central limit theorem, right? It says if two conditions are met, all different probability distributions can be approximated with normal distribution. So that's why nowadays statistics become so powerful because of this central limit theorem. Okay. So this, we call this bell. So the areas under this bell curve and this horizontal line is 1, which means 100%. Which means 100%. And this just keeps going. So on the two sides, it keeps going. But it becomes, you know, it becomes very, very, very close to this horizontal line. And the empirical rule says this. Says, okay, the middle one is mean. So let me write the word mean. So the middle one is the center. We use mean to measure the center. Then we make this, we call one standard deviation, right? Let's use a simple value to see this mean happen to be 0, right? Let's use this. If mean is 0, so then this I call -1, and this I call 1. And this side I can keep going. I call this -2, -3. Towards the upside, I call this 2. I call this a 3. All right. Just a simple case. This is easier to understand. So what do we call this? This we call within one standard deviation. Right. So from -1 to 1. So in this case, this is saying the mean value is 0. The standard deviation equals to 1. So with the standard deviation, so one standard deviation apart, that's a 68% of the data values. So this is an empirical rule. This is what empirical rule tells us. I'm changing my color. And within 2 standard deviation apart, it's 95% of the data. Okay. Then let me use black color. Within 3 standard deviation, let me write on the bottom. 3 standard deviation apart, that's 99.5% of the data values. So you see only 0.5% is on the two ends. So this and this are only the rest of the 0.5% of the data, which is outliers, right? Outliers. So that's what is empirical rule for normal distribution. So for us, let's write down the numbers we have. So we're given mean to be 8.44. We're given mean to be, let me erase this. So mean is, oh, I forgot already. 8.44. Yeah, 8.44. So given the data mean equals 8.44, and the standard deviation is 1.49. So 1.49. So then we have to just redo those numbers, right? These numbers I put over here just for easy case, convenient case, easier to understand. So now a mean is 8.44. So towards the right, I'm going to add. So 8.44, let me use my calculator. So one standard deviation apart, I'm going to do 8.44 plus 1.49. So I get 9.93. So 9.93. Then I'm adding another one, 1.49. So that's two standard deviation apart. So that's 11.42. I'm going to add one more. That would be three standard deviation apart. So this would be 12.91. Right? So towards the left-hand side, I'm going to subtract. I'm going to do 8.44 subtract 1.49. So this value should be 6.95. Let's subtract another 1.49. That's 5.46. So what I'm doing here, I'm just keep towards the right-hand side of mean, I keep adding the standard deviation. Towards the left-hand side, I keep subtracting the standard deviation. So 5.46 minus 1.49, I get a 3.97. So what does this tell us? This tells us for this set of data with a mean of 8.44 with standard deviation 1.49, 99.5% of the data sits in between 3.97 and 12.91. Okay, now let's go back to the question. The question is asking, what percentage of American women have shoe size that between 5.46 and 11.42? Let's find those two numbers. We need to find the 5.46 and the 11.42. So let's use blue color. Blue color, I don't know why it doesn't give me blue color. Okay. So I need to find the value 5.46 and 11.42, right? So we compare this. So 5.46 is right here, and the 11.42 is right here. What does the empirical rule tells us? That's 95%. So that's it. The answer is, we don't really have to write it, but the question is asking the delta value in between 5.46 and 11.42. What is the probability of that? That's 95%. Okay, so that's the answer for this question. It's 95%. All right. Okay, let's go back again. So this might be a little bit difficult to digest right away. So bell curve or bell curve distribution, which is called a normal distribution, is one of the probability distributions, and is a very powerful distribution because of central limit theorem. So I'm missing I here. It's EMPIRICAL. Empirical rule is saying this. Within one standard deviation apart. So this is mean. Mean sits in the middle of this bell curve. One standard deviation apart, which means we use the mean, subtract the standard deviation to get this. Add standard deviation to get this. So one standard deviation apart is 60% of the data. All right. So that means in this data set, we do not know this data set, but we know it's described with mean of 8.44 and standard deviation of 1.49. So we know 68% of the data sits in between 6.95 and 9.93. Okay, that's these two values. And the 95% sits in between 5.46 and 11.42. And the 99.5% sits in between 3.97 and 12.91. So this tells us how powerful the distribution, if we know the mean and the standard deviation of a data set. Okay, if this is still confusing, surely I'm going to talk more in the class.